Hello, everybody. Hi, it's my pleasure to be speaking to you today. I'm Tracy Miranda at ChainGuard, and I'll be speaking to you today about a blueprint for secure open source software supply chains. Bit of a mouthful, but let's get into it. I'm going to start with a little bit of an introduction for those of you who've never heard me speak before. So I lead open source at a startup called ChainGuard, where our mission is to make the supply chain secure by default. And before that, I've been doing a bunch of other things in open source. So I was leading the Continuous Delivery Foundation, which is the home of projects like Jenkins, JenkinsX, Tekton, and Spinnaker, which is the project that powers Netflix. And before that, I was at CloudBees, and I'm also a veteran of the Eclipse Foundation. So I've been working for over 20 years in open source, and I really love all the communities there. So I mentioned earlier, I worked with the Jenkins community. And Jenkins is an amazing project, and so many people use it to deliver software. But one of the interesting things when I started at CloudBees and I was leading the community team there, I had the Jenkins security officer reporting up to me. And it was really eye-opening because Jenkins is used on these super powerful machines, and they would constantly have to deal with folks who have had exploits or different vulnerabilities. And one of my favorite ones at the time was I say favorite, but it was pretty serious, but a little bit amusing, that these hackers had exploited these Jenkins servers and managed to get away with 3 million by mining some form of Bitcoin. And it all came down to the Jenkins server being unpatched. So this was a taste of kind of this aspect of what we call software supply chain security. So we as an industry, we've been running software for decades, and we take lots of steps to protect the application and to protect the infrastructure running in production. But then very often it's running on an unsecured Jenkins machine, which is like sitting under people's desks. And it really has become the case that this has started to become more and more serious just in the last few years. And in fact, there's a report from Sonatype. They put out the state of software supply chain security. And what it showed that in 2021, attacks had increased 650%. And previous to that, they were going up, but last year was pretty dramatic. And you may remember the SolarWinds exploit was one of the most notable, but there were also others such as CodeCurve, as well as Travis Secrets leak. So a couple of ways to think about this. On one side, it's actually a good thing that we've gotten a lot better as an industry in securing our applications. But it does mean that attackers have moved on to trying to attack the software supply chain. So the way we build and deliver software are now increasingly under attack. And then the problem is somewhat compounded due to another factor. And what we see today is open source, which, as I said, I'm a huge fan of. It really has become a critical part of our whole global infrastructure. So we like to talk about software is eating the world, but really what's underpinning all that software is open source. And to give a specific example, when it comes to cloud infrastructure and cloud native developers, we talk about that ecosystem being about 6.8 million developers. And of that, about over 5 million are using Kubernetes, the open source project, which has gained massive traction. So we've got all this open source forming part of the supply chains, and it's that which we have to look to protect. However, it's not that simple, because if you break down the software supply chain, what you do find is that there are just a number of different points of attack. So in this diagram, you'll see every red triangle is a different vector point, a different attack vector which somebody could take advantage and which you have to protect against. And that's not all, because if you see the box which talks about dependencies, the dependencies are actually each open source project you use, and each open source project will typically use other projects. And as we like to say, it's tether all the way down. So for every open source project, it's got its own supply chain, and that has to be secured. So there really is a lot at stake. There's just a huge surface area to try to figure out. Where we stand today is they aren't really great solutions. Most of the solutions in the space are very fragmented. They'll tackle one part of the solution, and they're often what we call like bolted on rather than baked in. So a bit of an afterthought, which of course isn't ideal. And then there's the ever-present concern that like developers don't want to focus on security solutions that make them change their behavior or slow them down in any way. So we really need solutions which are developer friendly. So one of the things that's happening last year as well, the US government issued a cybersecurity executive order because of such exploits as the SolarWinds. And as a result, we're going to see increasing regulation on the way, driven by the White House. In particular, the NIST guidelines around Secure Software Development Framework, or SSDF, were released earlier this year. And this sort of maps out different ways organizations should be thinking about securing not just their applications and their production infrastructure, but their secure supply chains. And it's something I've written a lot about. You can check out the blog where we've written some posts about how to approach this. But that's pretty much what I'm going to be doing today, is giving some thoughts about how open source projects can secure their supply chains and make sure that all the applications that use them can take advantage of those benefits. So yeah, just to summarize some of the issues we're having to contend with and why this is important. We've had these policies out there, yet there's no real automated tooling that helps run it. Organizations who use that open source don't necessarily know what code they're running, where it came from, and how it got there. So when you have exploits like the log4j, it makes it super challenging to figure out, are we vulnerable to this? If you can't even answer that, that makes things tricky. And then also, when it comes to securing supply chains, it's a big team effort. It needs interaction from different teams, the security teams, developer teams, operations. So it's important to kind of bring people together. Another compounding factor is just that there is this lack of cybersecurity professionals. Security today is everybody's job, and that's why we'll be talking about some projects in open source that can help. So I like to say, some people will like to say this is an open source problem, but equally, I also think open source is the best way to solve this challenge. So I'll be talking to you specifically about how do we go about doing this and proposing a blueprint. So like a way we can apply this to any open source project, and a bit of a methodology to go about this in a systematic way. And I'll be basing this experience on some work we've been doing with the Kubernetes community. So as I mentioned, huge community used by over 5 million developers. But yeah, I was able to kind of observe how they've been going about observing their supply chain. And it really is pretty applicable to many projects out there. Before we jump into the solution, I'd like to highlight a few qualities of what we're looking for. So if we want security to be done well in open source, it's really important that it's easy. All these millions of open source developers and users aren't going to take advantage of the solutions if they're not straightforward. And they must be comprehensive. We can't just deal with one side of the problem. Traditionally, we've done a lot of vulnerability scanning, which is great, but there are other attack vectors that have been left unchecked. And it's always important, to lead with open source and not to kind of ignore it or pretend it doesn't exist. First of all, I want to highlight a pretty key project that's emerged over the last couple of years, and it's called Supply Chain Levels for Software Artifacts, or SLSA. So it's kind of debatable whether that SLSA also refers to the dance or to the food. I have a slight preference for the food, but yeah, totally up to you. And you'll see that the logo is the dancing goose in a salsa dress. So salsa actually originated from folks at Google who had a internal system which they would use to assess their software and security around artifacts. However, what they were looking for was a way that this could be applied to open source. So SLSA emerged and grew up in the OpenSSF community, which brings together different players, and you can see a list of a lot of different vendors who've gotten involved to help evolve this roadmap. And what it is 4 different levels by which you can assess the security of your artifacts and the surrounding systems. And it looks at different things from builds to provenance, and breaks it down into different requirements for the 4 levels. So it can start off at, pretty straightforward. You can start off at SLSA level 1, which is just looking to say, have you documented your processes, and have you got things in place for higher SLSA levels? And then it goes all the way up to SLSA level 4, which is a pretty strong, robust way of saying our systems are secure. SLSA has been gaining traction, and in fact, we're seeing a lot of companies actually looking to adopt it this year as part of their OKRs, saying, okay, we want to get to SLSA level 1 or get to SLSA level 2 by the end of the year. And it's pretty great that the system, which is designed for open source, also translates really well to systems used by company and enterprise software. And I love this quote from Michael Lieberman of Citi. He says, if your build pipeline is the meal, SLSA is what gets poured over to complete it. So we're going more into SLSA and how it got used in practice by the Kubernetes community. Early last year, the Kubernetes community decided that they were going to very proactively try to improve their SLSA levels. And how they went about this is they created a spreadsheet and taking all the requirements for the different SLSA levels, and as a community went through each one and identified what the state of it was. And they sort of used traffic patterns to say, is this green, amber, or red? So as you can see in the slide here, this gives you a little taste, and that's a public document. You can go and have a look at the link at the bottom, which talks through their process. So the really cool thing is they were looking at improving their SLSA levels, but also doing it in a very open and transparent way, which is great for other open source communities to learn from. So in their assessment, one of the first things they looked at to meet the requirements was whether they could implement a software bill of materials, commonly known as an SBOM. And the idea of a software bill of materials is it gives you like a receipt of components that go into building a release. And this is something you'll probably hear a lot of, not just at this conference, but a bit more widespread in the industry, as SBOMs are becoming more prevalent, and indeed there might well be some regulation around requiring every piece of software to be able to say, what is it made of, where did the components come from, and being able to track that back. So you can think of an SBOM almost like the ingredient list on something you'd buy at the grocery. So it's a little more complicated for software. But essentially, it's a good list of things that go into making up that component. So the SBOMs were implemented, and this allowed the Kubernetes team to get to SLSA level 1. As well, the SBOMs weren't the only requirement, but that was one of the key things they implemented. And that was achieved in the 1.23 release, which happened at the end of last year. So to get to SLSA level 2, the Kubernetes team needed to meet requirements around provenance. So this is all about saying, how do we make sure that when people download our software or go to use it, what they're getting is exactly what it claims to be? Or even if we provide them an SBOM, how do they know that hasn't been tampered with? You know, it's the idea of getting something that's tamper-proof, and you can verify that the people who you think built it actually did build it. The solution in this case is what we call software signing, and they're looking at a relatively new project called Sigstore. Now, Sigstore is an open source project which is becoming a new standard for signing, verifying, and protecting software. And while software signing has been around for a while with systems like GPG or PGP, one of the key innovative things for Sigstore is that it effectively does what we call keyless signing. So spoiler, there are keys in the signing, but they are short-lived ephemeral keys, which means after you sign artifacts, that this is recorded in a public transparency log, and the keys are discarded. Now, the benefit of this is that traditionally having to manage keys is a bit of a pain, or it's very easy to compromise the keys, or to have the analogy is developers will sign something and then hide the key under the doormat, and then it kind of leads to another vulnerability point, because then it takes away all the benefits of having signed something if it can be exploited. But Sigstore, because it looked at technologies like Let's Encrypt and was looking to kind of follow a similar pattern, it really has a great user experience, which means that not only are the Kubernetes community keen to adopt it, but also language communities like Python and Ruby, as well as package managers like Maven are also looking at implementing Sigstore for signing. And there's a number of companies as well, like HPE, Bloomberg, Citi, and even the Department of Defense, who are looking at Sigstore and integrating it into their products. So essentially, with code signing, you look to sign the code, but it also means then your users can verify those signatures, and it includes a public log where folks can monitor activity. And I won't go into this in great detail, but just at a very high level, developers can request a certificate. Sigstore comes built in with its own certificate authority, which will issue the certificate. As we mentioned, keys are only short-lived, so that the transaction gets recorded in the log, and then the signed artifact can be made available to your users. And then your users are able to verify the signatures and take advantage of the transparency and the trust root model that exists with Sigstore. So yeah, it just makes it super easy and super straightforward, and as one of the key reasons the Kubernetes community decided to implement it. However, that being said, there were still lots of challenges that had to be overcome. So some of the key ones were, how to connect the identity, who's going to sign it. And then Kubernetes also has lots and lots of artifacts. So they produce artifacts for all sorts of different architectures. So I think in total it's something like over 80 different types of things that get produced. And then the other challenge they had to deal with is that they also have a number of mirrors. So Kubernetes is a worldwide project. It's used lots of different continents. And to make it easier, it gets mirrored to all these places. So again, even dealing with these over 80 artifacts going out to different places in the world, they wanted to make sure that it could be signed and then these things could be transmitted. And it was really straightforward to still verify that the version you picked up is exactly, was built by the Kubernetes team. No one had interfered with it. Nobody had introduced something with malware, and it was, secure by default. This was a huge achievement, which took many, many months of work. And it did involve coordination with a number of different teams. Not only did they have the release SIG, but also security SIG and other teams. A big shout out to my colleague Adolfo, also known as Puerco, who was one of the key folks leading that effort and working with the rest of the community to make sure that they managed to deal with all the different challenges that came their way. So this happened just in May, where the Kubernetes 1.24 release went out, and it was the first release that enabled signing for all the different artifacts. And so this meant for the very first time, those over 5 million developers could have this extra level of assurance that what they were using had not been attacked. So yeah, huge milestone, and really, I think the community were really thrilled with that. And that meant they then achieved the next SLSA level, which was SLSA Level 2. The community is continuing on that journey. It is a continuous road, and I think they now have their sights set on SLSA Level 3, which introduces additional requirements on the build and provenance side. And they'll be working towards that when it comes to SLSA Level 3 and maybe even looking at SLSA Level 4. But I think the key thing there is they're just taking it one step at a time and working to get everybody on the same page and deal with all the challenges that come up. So I've kept it very high level. There is a lot of information out there about securing supply chains, and it can be kind of very challenging to dissect all the different information, which is why what I want to highlight with this talk today is kind of some key steps, which I think are some of the most effective things you can do for any open source project using open source tooling, which makes it super easy and without getting bogged down in too much trying to evaluate all sorts of different tools and things out there. These are sort of the most effective things you can start with. And then once you've got these in place, there's lots of, there's a never-ending list of things you can do to improve. So yeah, step one, I encourage everybody to take a look at the SLSA project that's on salsa.dev and go through an evaluation with your open source community and, just be really honest with yourselves. This is, there's no place for shame in it. Everybody should come into it pretty open with this commitment of saying, nobody's got perfect security out there. I don't think there is such a thing. So just meet yourself where you are and start by just evaluating where you are on the different requirements for SLSA. And then the next thing is to take those incremental steps to improving. So pick some low-hanging fruit and start there. Implementing SBOMs, there's SPDX and CycloneDX are kind of the two main frameworks, and they are increasingly more and more tools that are being made available in open source and beyond that make it super easy to add an SBOM to your open source project. Then in addition to that, code signing is a critical part to make sure things have not been tampered with. and Sigstore is like becoming the de facto solution there. A lot of the language communities are already looking at integrating Sigstore, so it's worth checking with the Sigstore community if there's somebody already doing work, because you might find it's already becoming easier for communities like the Java community and Python community. They're starting to become Sigstore clients, which make it super easy to use. And speaking of asking the open source community, there is the Open Source Foundation, known as the OpenSSF, is becoming the new home for folks who are looking to improve the security. It's the home of projects like Sigstore and SLSA, and it has a lot of open communities which anyone can join to learn from peers in the space about how to go about doing that. Encourage folks to check out the OpenSSF, check out the many communities under it, like the SLSA community, the Sigstore community. There's one for package managers, and folks are super friendly and looking to help and looking to share knowledge. And yeah, a lot of the problems in the space and things around identity, they're all ongoing, and everybody's working together to try to work out the best solutions. And then, yeah, take some baby steps and just rinse and repeat. Look at doing that again. And yeah, I think the only failure here is not trying or not going for it, because in a year's time, I think it's going to be the case that most people will expect things like SBOM and software signing to be table stakes. And yeah, really, it's the only hope we have of protecting open source and really all the software that builds on it. So happy to leave it there. Happy to take any questions. I'll be hanging around in the chat after this talk. And also you can reach me at Tracy Miranda on Twitter, or in the OpenSSF community in the Slack channel. So happy to answer any questions. And thank you very much for having me today.